Okay, so we are going to start on page 9 today, and I'm going to go over some practice problems that match up with the stuff we talked about last time in class. So we had started our sampling, inferences, and conclusion notes. We didn't get all the way through them. We stopped with the idea. Let me flip back here really quickly. We stopped with the idea that if I want a good sample size, or if I want accurate information, I should say, we should have a decent sample size. And so the last example that we looked at was Ernie working in that rubber duck factory. And we said, if he's only checking a very small portion of the ducks, I think he checked 10 out of 100,000. That's not enough to really be able to make any decisions. I need a larger sample size there. So that's what we got through. So we're going to do the practice problems that kind of match up with that information. So on page 9, we're going to start with number 1. Number 1 says, what's the difference? This is some vocab here. What's the difference between a target population and a sample population? So flip back in your notes if you need to. These were 2 terms that we defined last time. Target population versus sample population. What am I looking at there? Target population versus sample population.
Target is everyone is able to respond to a survey or a poll.
Yeah.
And then sample is only a group of people that are able to respond that are picked out.
Yeah. So our target population is everyone, or if we think about that rubber ducky example, everything you are interested in. The sample population would be the group that you actually check in with. Group that you survey or inspect. Excuse me. Okay, so target, if I could ask every single person whose opinion I care about, that's the group that we're talking about there. The sample are the people I'm actually able to talk to. Okay? Or my target might be all the rubber duckies. My sample are the rubber duckies I actually check. Number 2, the students in a statistics class took a random sample of 50 colleges and universities regarding student fees at the 50 institutions and concluded that their own fees were higher than at most colleges in the country. What's the population and what's the sample? The sample sometimes is easier to start with. What's the sample? Who did I survey? How many? Yeah, I surveyed 50 colleges. Colleges/universities. I surveyed 50 colleges and universities. So 50 colleges and universities surveyed. Who do you think might be the target population then? We surveyed 50 colleges and universities. What do you think would be the broader groups that I'm trying to get information about? I'm not surveying the students though. All the colleges and universities, right? If I surveyed a group of colleges and universities, that means I'm interested on information about colleges and universities. Sometimes, again, it's easier to start with a sample. Sometimes it's easier to look at who did I specifically talk to or what did I specifically inspect, and then look at that bigger picture. We're going to skip number 3. We have not talked about the material that relates to number 3 yet, so let's hop down to number 4. Number 4, you flip a coin 3 times and you get tails each time. Your friend says that based on your results, this means that the probability of flipping a head is not 50% as you previously thought. Is your friend correct? No, right? So why is your friend not correct? Mhm.
Because then you take 1/2 times 3, and you get like 6/1, 1/6. So you have like 1/6.
So what you're, the road that you're headed down towards is the probability that I would get 3 heads in a row. Not quite what we're after here. So like put the math part of it away, put the computation stuff away. I still got 2 sides of the coin, right? And then I want you to think about our rubber ducky example from the other day. We checked 10 rubber duckies and we said that wasn't good enough. Why was 10 not good enough? It was too small of a sample size, right? So we flipped a coin 3 times and said, well, that's the probability then. I guess we're always going to get tails. Is that reasonable? No, right? No, that sample size is way too small. Now, is it very likely that we flip a coin 3 times and get tails every time? No, and that's kind of what you were heading me towards. So could we calculate the probability that we flip and get tails 3 times? Sure. Is it going to be very likely? Probably not. Is it possible? Absolutely. But I can't say that the probability of getting heads versus tails has changed based on a sample size of 3. Okay. No, you can't draw conclusions based on a sample size of 3. Maybe I can do a simulation and flip a coin 1,000 times, and then I might have a more accurate set of data to be able to say, hey, maybe that probability is not actually exactly 50-50, based on, I don't know, the way the both sides of the coins are shaped. Maybe it skews it one way or the other, but based on 3 flips, I can't say that. And based on 3 flips, I don't even have the option to get 50-50, right? So 3 flips, at the most even it could be would be 1 to 2. So I didn't even put myself in a position where I could get 50-50. Questions for me so far? Okay, turn the page, and the last one we're going to talk about today is number 5. Number 5 is the last one that relates to the work that we did last time. So number 5 says determine what type of random sample. Remember we talked about 3 different types of random samples? Determine what type of random sample has been used in each of the instances below. If the sample is not random, state so. So we've got 4 choices here. Simple random, systematic random, stratified random, or not random. Okay, 4 options. Part A, each student at a school has a student identification number. Counselors have a computer generate 50 random ID numbers, and those students are asked to take a survey. First, is this random? Yeah, we used a random number generator, right? Everybody's assigned a number via their student ID number. That sounds familiar. You guys all have student ID numbers. And then we had a computer randomly output 50 of those ID numbers. That's a random sample. What type of random sample? Simple, systematic, stratified. Flip back in your notes to those definitions if you need to. Not quite. Sample is not the word you're looking for. Simple, there we go. Simple random sample. This is a simple random sample. B, a principal orders t-shirts and wants to check some of them to make sure they were printed properly. She checks the top shirt in the box closest to her desk. Is this random or not? Why is this not random? Yeah, I checked one shirt. So like technically that's a sample, but it's definitely not a good sample. Each box didn't have an equally likely chance of being a box selected. Each shirt in the box didn't have an equally likely chance. This is simply like a survey of convenience. Okay, so this is not random. Part C, a school chooses 3 randomly selected athletes from each of its sports to participate in a survey about athletics at the school. So I picked 3 athletes from each sports team. So of all my population that possibly could have been selected, I divided that population up by what sport you play, and I picked some athletes from each sport. What would this be? This is stratified, right? I broke them up into groups first. Good. And then finally, D. While students are lined up for school pictures, a teacher passes out a survey to every 10th student in line. Every 10th student gets a survey. This is systematic, right? The difference between systematic and simple is for simple random samples, we're typically using a random number generator, or we're drawing names out of a hat, something like that. For systematic, we're choosing every 10th or every third, something like that. So anytime you have a systematic sample, there should be a system described in there for how we're making these selections. So, and it should have something like, I pick every 10th, I pick every third, something like that. So this is systematic. Very good. Okay, that is it for our practice problems for today. Those are all the ones that align with the work that we've done so far. So let me get our notes turned off and we will switch gears for the day.